Hello everyone. So today I want to start off today's lesson by setting up a race. Now this isn't going to be a typical race. This is going to be a race of numbers. But here's the first competitor in our race. We have this function. It's called y equals 2x. And the race is going to be a race to 50. The question is, which one of these functions is going to be the first to reach 50? Let me show you how we can kind of set this race up. I'm going to write here in my x column, I'm just going to write the number 0, 1, 2, 3. And I'm going to pretend like x is like the number of seconds in this race. Well, after 0 seconds, if I plug 0 in for x in this function, 2 times 0 is 0. At 0 seconds, this function has traveled 0 steps, or 0 feet, whatever you want to call it. After 1 second, 2 times 1 is 2. After 2 seconds, 2 times 2 is 4. After 3 seconds, 2 times 3 is 6. The question is, how many seconds is it going to take for this function to reach 50? Okay? And then comparatively, how long is it going to take each of these functions to reach 50? Which one will get there the fastest? Go ahead and hit pause on your video here in a second. And I want you to actually work out this race. See if you can figure out which of these is going to be the winner, which one is the fastest to 50. Go. All right, and I hope you were able to find a winner in this race. Let's kind of break these down one at a time. See how long it took each of these to get to 50. Now the first one, it would have taken you a while to write out the entire list. You could have kept going with this pattern over and over. But hopefully, if you just kind of think 2 times blank equals 50, hopefully that's one you can basically do in your head. This function would take 25 seconds to make it to 50. And make it whatever you want, 50 feet, 50 yards, whatever. We'll say yards, okay? It took 25 seconds to make 50 yards, okay? Really is not that fast. If any of you have ever tried doing like the 50-yard dash, not very fast at all. Now, and so that's y equals 2x. Now as we look at this next one, y equals x squared, hopefully you're good at like squaring numbers in your head. If you do 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc., you're going to see it gets really close at 7 seconds. At 7 seconds, it's made it almost there. It's made it to like 49 yards. At 8 seconds, it's a little bit too far. So we know the answer here is going to be somewhere between 7 and 8. Okay, don't know exactly, but it's going to take between 7 to 8 seconds for this function to make it 50 yards. Now this one over here is a little bit harder. This one, I'm actually going to enlist the help of a calculator here. Okay, here, this doesn't mean 2 times x. This means 2 to the x power. All right, so if I take 2 to the 0 power, I get 1. This one actually gets a head start, you'll see. Okay, it actually gets to start at 1. And then if I start taking 2 to the first power, 2 to the second power, 2 to the third power, you're going to start to see a pattern. 2 to the fourth power. If you look, the number here, it actually doubles every time. See, what like 2 to the third power means? This actually means 2 times 2 times 2, which is 8. 2 to the fourth power means 2 times 2 times 2 times 2, which is 16. And then if we add in with 2 to the fifth power, if we add in another times 2, that number is just going to keep doubling every time. And you'll see that this one's actually the fastest. This one is going to make it to the 50-yard line somewhere between 5 and 6 seconds. Okay. Now, if you want exact answer, so this one we have the exact answer is 25. If you want the exact answer here, we would actually do the square root of 50. The square root of 50, it comes out to like 7.071 approximately. So approximately 7.071 is kind of the precise answer. That's how many seconds it takes this one to reach 50. Now, if you want this one, okay, I'm going to show you how to do this one. You're going to be scratching your head like, how did he come up with this? We actually have to do the log of 50 divided by the log of 2. Okay, and this one actually comes out to 5.6, approximately 5.644. Now, if you're sitting there wondering, how did you come up with that, Mr. Klein? Well, this is what you're going to learn in this chapter, is how to solve these types of equations where the x is in the power. All right, now each of these has a name. This y, the 2 times x, that's called linear. The x is to the first power. You can imagine an invisible 1 right here. This is called a linear function. It gets the job done. It was kind of slow. It was slow and steady, right? This one is slow and steady, but you can see it gets the job done. It gets there eventually. This is almost like, if you know the story of the tortoise and the hare, this one's kind of like the tortoise. It gets there. Slow and steady, it eventually gets there. Now this x squared, we've already learned, this is called a quadratic function. Anytime you have an x that's being squared, this is called quadratic. And you can see that this is faster. Okay, it gets there significantly faster than the linear does. But over here, what if our power is an x? What if you have something to the x power? This is what we're going to study in this new chapter. This is called an exponential function. And what you'll find, exponential is always the fastest, but there's a catch. In the long run. It's not always the fastest right off the bat. It's not always the fastest right out of the gate. But in the long run, exponential growth always wins. And, if you kind of compare, like, let's look at like 3 seconds. Let's look after 3 seconds. After 3 seconds, linear had made it 6 yards. Quadratic had actually made it 9 yards. Exponential had only made it 8 yards. Here, after 3 seconds, you'll see that quadratic is actually in the lead at that point. So exponential, it doesn't always win in the short term. In the short term, sometimes it gets beat. But if you give it enough time, it will always win in the long run. So for the rest of this lesson, we really want to compare the difference between linear growth and exponential growth. And these examples that you see here, this is really what your assignment is going to be about. Okay? A $100,000 investment gains $800 every year. Find its value after 3 years. Okay, well, if I were to do this step by step, if I have $100,000 and I made a typo here. This should be $8,000. I'll make sure I'll fix that in our notes, our class notes. Okay, but I'm sorry, this should say it gains $8,000 every year. Well, to do linear growth, right, it's slow and steady. All I would do is I would just keep adding $8,000 every year. So at year 1, I'd have $108,000. Add 8,000. Year 2, I'd have $116,000. Add 8 more thousand. In year 3, I'd have $124,000. Okay? Slow and steady. Every year it goes up $8,000. And so I could solve this step by step. Here's how a lot of people would solve a problem like this, and that's fine. Just take 100,000 and add 8,000, add 8,000, add 8,000. Boom, you have your answer. Now there's a faster way to do it by formula though. We've already learned the formula for a linear function, y equals mx plus b, and write this formula down if you haven't already. Here's how this formula works. Y is kind of in this formula. Let me write these out here. Okay, here's what each of these variables means in the formula. Y is your new value. It's going to be like your final answer that you want to get. M is how much does the investment increase every year. That would be the $8,000. X is the number of years. Okay, in this particular problem, that would be 3 years. And then B is the starting value. How much was this worth at the very beginning? And so using this formula, we can actually answer this in just one step. If we take 8,000 times 3 plus the starting amount, 100,000, here we can get the answer. With the formula, we can get the answer in just one quick step. It is $124,000. And I want you to see this because now, think of why this formula works. Think of this. If you add 8,000 3 times, isn't that the exact same as taking 8,000 times 3? And so this is what these formulas aren't just random, okay? They weren't just pulled out of a hat. These formulas make sense. If you think about what you're doing step by step, the formulas are just a way to do all of that instantly. Instead of adding 8,000 3 times, why not just add 8,000 times 3? to your starting value. Okay, so that's the linear growth. That's what linear growth looks like. Here's how we would do linear growth step by step. Here's a formula we can use to make it faster so we can do it all at once. Okay, let's move down now to, let's compare this now to exponential growth. So exponential growth, here we still have a $100,000 investment. Okay, that hasn't changed. That's still our starting value. But this time, it doesn't go up by $8,000 every year. This time, it goes up by 8% every year. It goes up by a percentage, and that's key. Find its value after 3 years. Okay, well, we did a little, we've done some reviews on percentages lately. So let's remember how to do this step by step. If I want $100,000 to grow by 8%, what I do is I multiply it by 1.08. Okay, 100,000 times 1.08. Okay, that equals $108,000. Okay, it grew by $8,000 in that step. But watch what happens the next time I do this. So this would be after year 1, it would have $108,000. But now I need to take this $108,000 and now I need it to grow by 8%. And watch what happens. It actually goes up by a little bit more this time. This time it doesn't just go up another $8,000. This time it actually goes up by $8,640 because 8% of 108,000 is more than 8% of 100,000. So you see it tacks on this little bit extra here that you don't get with linear growth. All right, and now I need to do this one last step. Now I take 116,640. I times it. I make it grow by 8%. I times it by 108%, so it grows by 8%. $125,971.20. This after year 3. Do you see how exponential growth grew by an extra almost $2,000 compared to our answer up here for linear growth? Here was our linear growth answer, 124,000. Exponential growth, it started the same after year 1. There was no difference, but it tacks on a little bit more each time, and so it grows faster than linear growth, and it always will. If given enough time, it will always grow faster. All right, now let's come up with a formula for this. So yes, you can do this step by step. If we multiply it by, an 8% growth, if we multiply it by 1.08 and do that 3 times for the 3 years, that's how we can do it step by step. But there's actually a formula to make this faster. And let me write out what all of these mean. And all of the variables in this formula mean the exact same as the variables in our linear growth formula, except exponential growth does not have a slope. It does not have an m value. Instead, it has an r value, and this represents the percentage growth each year. Okay? Because exponential growth, it doesn't change by a slope. It doesn't change by a steady slope every year. No, it changes by a percentage each year. All right, so we plug these in. Here to solve for y, we could find this answer in just one step if we know what we're doing. If we take our starting value, which is the 100,000, we times it by 1 plus the percentage growth each year. Now 8% as a decimal is 0.08. And then we take it to the x power. Okay, x is still the number of years. So we're going to take this to the 3rd power. Now I do like to, me personally, I like to go ahead and add what's inside the parentheses first. I like to combine this 1 plus 0.08 and just make it 1.08. But watch, we can get this answer in one step using our calculator. 100,000 times 1.08 raised to the 3rd power. And watch, in one step using the formula, boom, we can jump straight ahead to our final answer, 125,971. And don't forget the 20 cents. Why does this formula work? Think about it. Here we were just multiplying 1.08 and we were doing it 3 times. Well, think of what a power does. When you raise something to the third power, that just means multiply by 1.08 and do it 3 times. So this formula works. And hey, I want to make one last point before we do a problem off the assignment. Yes, I could have just shown you the formula and been done with it. But it's so hard. You're not going to just memorize formulas your entire life. When you're out of high school, you're not going to have all these formulas memorized. But if you understand the concept behind it, if you can see remember the step by step of how to do it, then you don't have to memorize the formula. The formula is just intuitive. It just makes sense. And instead of memorizing it, you understand exactly what it's trying to accomplish. All right, so I know how some of you are. Some of you are saying, skip the explanations, Mr. Klein. Just show me how to do it. Cut straight to the chase. So here you go. Here's 2 of the questions off of your homework. Question 1, $2,000 investment grows by $200 every year. Find its worth after the 5th year. This is clearly linear growth. It goes up by $200 a year. I'm going to write down my linear growth formula. I'm going to say the slope is that it goes up $200 every year. In this case, it's years. If it's like, sometimes it's every month or every day or every whatever. In this case, it's years. The time is that we want it to go for 5 years. And the starting value was 2,000. All right, you don't even need a calculator. You might not even need a calculator for this. This would be 1,000 plus 2,000. The answer is $3,000. It says do not type a $sign in your final answer. So you'll just write 3,000. We know that means dollars. Canvas just won't accept it with the $sign. Okay? Now question 2, a $2,000 investment grows by 10% every year. Find its worth after the 5th year. This time it's exponential growth because it goes up by a percentage. So we use the exponential formula. By the way, I use these. Sometimes people use different letters than these. I'm using B. Sometimes people use a P here instead of a B. I like to use B because we already know it as the starting value. All right, so we have the starting value is 2,000. The percentage is 10%. Now make sure you write that as a decimal correctly. And then the number of years, it's the 5th year. All right, so yeah, I don't want to do that in my head. I don't know if I could do that in my head. So grab a calculator. All right, here's how much that investment would be worth after 5 years. Notice exponential clearly outgrows the linear because exponential is always faster in the long run. All right, hey, best of luck on this assignment. Take care.